Tropical cyclones rarely reached Category 5 strength in the South China Sea. In September 2024, Typhoon Yagi reached it twice. The storm was moving directly toward northern Vietnam and China's Hainan province. Together, these coastal regions form a massive, highly concentrated hub for global manufacturing, shipping, and agriculture. Yagi began as a standard tropical depression. Locally known as Enteng, the system crossed the mountainous terrain of the Philippines, which temporarily capped its strength, before drifting westward into the open waters of the South China Sea. Here, it encountered a perfect meteorological engine. Surface water temperatures exceeded 30 degrees Celsius, providing immense thermal energy. Simultaneously, vertical shear, the change in wind speed and direction at different altitudes, remained weak, allowing the storm's structure to stack and build without being torn apart. This chart tracks the storm's wind speed, highlighting a massive vertical leap. Meteorologists classify this as rapid intensification, a process where maximum sustained winds increase by at least 35 miles per hour within 24 hours. Yagi's winds exploded to 270 kilometers per hour. Yagi became the strongest typhoon ever recorded in the South China Sea. It broke the established limits for cyclone intensity in this specific basin, forcing forecasters to reevaluate the maximum potential of regional storms. Looking at a timeline, Yagi tracked due west on a collision course with China's Hainan province, making its first major landfall near Wenchang. Weather stations recorded a pressure drop to 921.7 hectopascals, the second lowest MSLP in China since 1949, indicating an incredibly intense storm. The physical devastation was absolute. Heavy industrial equipment collapsed, and over 57,000 buildings across the province sustained serious structural damage. Hainan suffered catastrophic losses because the prolonged extreme wind pressure simply exceeded the physical tolerances of modern regional infrastructure. Standard meteorological models predict that landfalls strip tropical cyclones of their energy. As Yagi dragged across the Lijiao Peninsula and entered the Gulf of Tonkin, it weakened to a Category 3. But the warm Gulf waters provided a second fuel source. Yagi utilized a brief pause to undergo an eye-wall replacement cycle. The degrading inner ring of thunderstorms was replaced by a larger, tighter outer ring, allowing the vortex to restabilize and violently re-intensify. This data summary shows the result. Yagi slammed into Vietnam as a Category 4 storm with sustained winds of 230 kilometers per hour. It was the strongest storm to hit the nation in 70 years, striking directly through Haiphong and Hanoi. Massive metal facades were peeled back. Factory roofs collapsed inward. Entire industrial parks were shredded under the sustained force of the wind. This UNOSAT satellite map reveals the secondary threat. The storm carried an immense moisture footprint inland, dumping historic volumes of rain that triggered flash floods across the entire Red River Delta. Storms typically decay over land. Yagi's ability to survive a major landfall and rebuild its structure and strike a second country at near-peak intensity bypassed traditional emergency planning models. The human toll was devastating. Over 800 people died across the region, and millions were displaced as homes and farmlands vanished under the floodwaters. The crisis spilled far past the coastline. Yagi's remnants pushed deep into mainland Southeast Asia, triggering deadly landslides and completely submerging commercial districts in Laos, Thailand, and Myanmar. This chart visualizes the macroeconomic shock. Regional damage hit $14.7 billion, with Vietnam absorbing $3.47 billion, reducing its GDP growth by 0.15%. Beneath these numbers lies a logistical collapse. Surveys show 82.4% of supply chain businesses faced severe operational disruptions. With 300,000 hectares of agriculture destroyed and major manufacturing centers halted, the physical destruction catalyzed a secondary, invisible crisis. The region now faces a looming wave of defaulted commercial loans and multi-billion-dollar insurance payouts. Yagi acted as an extreme stress test for the interconnected global economy. It proved that a single meteorological anomaly can sever supply chains, stall manufacturing hubs, and erase national economic growth in a matter of hours. As ocean temperatures continue to sit safely above the 30-degree mark, these storm systems have the thermal fuel to intensify faster and strike harder. They are highly efficient, deeply destructive economic wrecking balls.